Hi everyone, welcome to the metric system. Today what we're going to do is talk all about the metric system and specifically how to convert units in the metric system. So really quickly, let's go through some of the basics of the metric system. Right? What is it? It's basically a standard way of measuring things that everyone in the world agrees upon. You want to know the way of measuring things that people use still here in America? The only country that really still uses anything other than the metric system? It's called the imperial system. Yes, it's the very old-fashioned way of measuring things that people still here in America like to cling to. But for the most part, we're only here in America using it. There are very few other countries that use the old-fashioned imperial system. Everyone else uses the metric system. So there are a couple basic parts to the metric system. There are first a few ways of measuring pretty much everything, right? There's the meter, which is, about as far as you can spread your hands apart. That's going to be 1 meter for it and everything. There is the liter, which is a way of measuring liquids. You use that if you go to the store and buy a 2 liter of something. That's the metric system right there. There's also, let's see here, the gram is the way of measuring how heavy things are, right? 1 gram, it's about 2.5 pennies, roughly, the mass of it. So 1 gram is not very much for measuring things. It take a lot of grams for an elephant. Let's see here. What else is it as far as the introduction to the metric system goes? Well, everyone compares things the same way when you're using the metric system. So, for instance, if you catch a fish that's as big as this fish right here, if you measure it in the metric system, you could tell your friend in Australia about it, and they know exactly what's going on. If you use that old-fashioned imperial system, feet, inches, they might not really know so much. They might be wondering what in the world you're doing. Do you ever wonder what in the world, where did feet come from? Right? So originally, they literally would measure the king's foot. And the problem came what happens if one country's king's foot is bigger than the other country's king's foot. Yeah, you can see where the problem is going with this and everything. And plus, it smelled bad and everything, right? So that's why those are some of the reasons we want to get rid of that and everything, right? Another reason for the metric system is it's neutral. Right? It's literally based on how big the world is, right? From one side of the planet to the other side of the planet. They kept dividing that by 10 until they got to 1 meter. Well, meter's bigger than that, but you get the idea here, right? So it was a neutral thing. So they measured one side of the planet to the other side of the planet and divided it by 10 over and over and over again, right? The liter, same thing, right? It's 10 centimeters by 10 centimeters by 10 centimeters squared, right? So if you can measure 10 centimeters by 10 centimeters by 10 centimeters, that's how big 1 liter is, right? So it's all still based off the size of Earth. 1 gram, it's basically 1 centimeter by 1 centimeter by 1 centimeter. So a cube, think almost the size of 1 dice or 1 die, depending on how you want to look at that and everything, but filled up with just pure water, right? That's where 1 gram comes from, right? So it's based off the size of Earth, right? The whole metric system. There's no one country is better than others, and our king was better than your king or anything like that, right? So that's why everyone uses it. It's easy to use. It's neutral. Right? Very, very simple. Okay, there we go. Why is it so easy to use? It uses powers of 10. Think about it. With the imperial system that you've been using, you have to count with 10, 11, 12 fingers. You don't have 12 fingers. Who in the world thought that was a good idea? But way back when they were creating the metric system, they said, we've got 10 fingers. We might as well base our units of measuring things off of 10, right? Which makes it much, much simpler. So when was it created? 1776, right? So think, about the time that America's being born here and everything. That's where over in Europe, they were creating the metric system, right? So that time. Who created it? The French did, right? The French were the original scientists that decided to create this system. So, if you like French bread, maybe you like the metric system. Countries that use it. Okay, there's not a whole lot right here. The countries in red are the ones that still use the metric system as their official, or sorry, not the metric system, the imperial system as still measuring, their official way of measuring stuff and everything like that. So yeah, you've got, you've got Burma over here, you've got little tiny Liberia and the United States, right? But think about it, every other country on the entire planet has said, yes, the official way we're measuring things is with the metric system. Well, there's always hope for us in the future, right? Okay, let's see here. The way of measuring things is all based on tens, right? So 1 is like those basic units that are right there in the middle, right? And everything else, it's 10 times bigger and 10 times bigger and 10 times bigger and bigger and bigger and bigger, always by the units of 10. Or it's 10 times smaller, 10 times smaller, 10 times smaller, 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 So you get, really, really tiny things. This year in science, it's kind of important to us because we're going to talk about some of the biggest things in the universe when we talk about astronomy, right? So that's why you need all of these zeros. We're also going to talk about some of the smallest things when we're in chemistry, right? So, talking about atoms and parts of atoms and things like that. So we use the metric system in physical science, so it becomes a little bit more important than some of the other sciences because of that. For the most part, though, we're just going to focus on just things kind of around the base units. This is where most of the time that you're measuring things in science, what you're using. So the steps of the metric system are these guys right here. These are the ones, like I said, that were, where is it? These are these are the steps that we're most commonly using. So when we show you this, the steps of the metric system, just understand it does keep going this way, and it does keep going that way, smaller and everything. But let's keep the numbers at least somewhat reasonable and everything. So we're just using these steps that are right here and everything. So why is it useful? Everyone uses it, right? It's sad in the sense that, yes, there's math if you don't like math. Some people like math, some people don't. All right. But we're going to have fun with this and everything, right? So let's kind of skip along here. Here we go. All right. So we covered this before. Cubic centimeter, 1 centimeter by 1 centimeter by 1 centimeter. Right. That's kind of the size of a cubic centimeter. Everyone knows how to find the decimal is the first step in this, right? So if 1776, right, is our number, where is the decimal in this question? Hopefully by 7th grade, you know that the decimal is that guy right there, right? Same thing. This one right here, where's the decimal? I'm hoping that you can find it right there and everything. But here we go. I've actually had 7th graders, when I ask them this question, where is the decimal in this number? They honestly answer either incorrectly or just tell me they have no idea and everything like that. Same thing with this number right here, 747. Where's the decimal? Hopefully you understand that even if the number does not have an actual decimal in there, it's still right here, right? It's still a decimal. You could write this number just by writing 747, or you could put 747 and then a little decimal right after it, right? Either way is correct when doing this. The steps of the metric system, right? There's the base unit. So either you have 1 gram, 1 liter, or 1 meter, right? Or the way that you make them smaller is you have a tenth of it, right? So you would call it a deci. If you have a hundredth of it, you'd call it a centi. If you have a thousandth of it, you'd call it a milli, right? As far as the base units going bigger, right? If you have 10 of them, right? Because remember, we're always increasing or decreasing by steps of 10. It's called a deca. Either 100 is going to be a hecto, 1,000 is going to be a kilo of them, right? That's where you get into like kilometer, right? Or deciliter kind of thing. You kind of link them together. The name of the main unit combined with how big or small it is. Either way. So you're always linking those prefixes to the base unit, right? So you could have a kilogram, right, or kilogram, deciliter or deciliter, millimeter, millimeter, right? They're just linking them together to show you how big they are, right? So that's what we're doing. We're always going to be linking those prefixes with one of the base units, right? Either to go down to make it smaller or make it bigger going up, those things. The steps of the metric system that we have. All right, let's gonna skip ahead here. All right, so okay, this is showing you the shorthand version of it, right? So these are the shorthand parts of it. So instead of having to write out the whole thing kilo, right, you could just put a K in there. If it was hecto, right, you could just put an H in there, right? And in fact, deci is D, centi is C, milli is M. If you have the base units, same thing. Meter is M, liter is L, gram is G, everything's fine until you get to this one guy right here, deca, right? The problem you have with deca is, well, deci is using D, so deca can't be D2, or else if you're just having, if you're just putting down just the initials, well, who would know which one it is and everything, right? So deca is the only one. It's DK for deca, right? So you could have a decagram, right? You could have a decaliter, or you could have a decameter, depending on how you have them combining together for it. So these are all practice ones, right? So if you have a milliliter, right, the way of saying it is going to be ml. If you have a centigram, right, the way of writing it is just cg. So already you can see it's much simpler, right? Instead of having to write out decimeter, well, you can just put dm in there, right? But when you get to decaliter, remember now, this is the tricky one, right? It's dk, right? So it's going to be DKL for decaliter. All right, so there you go. That's the only tricky one. But when he comes back to all the other ones, like hectogram, right? HG, kilometer, km, centiliter, cl, decagram, be careful with this one, yep, dkg, and then decameter, dkm, right? So whenever it's deca, there's an extra step in there for it. So all we're doing for converting is we're just taking this little guy right here, that little decimal, wherever it's at, and you're either moving it up, kind of like in our little picture right here, or you're going to be moving it down, right? That's the only thing that really you have to remember when you're converting those units, right? Oh, here, sorry, I'm skipping ahead here and everything. Here's a cool graphic for this one, right? Base unit, right? Meter, liter, or gram. It's kind of like you have one of whatever it is that you're talking about. Remember, going up the ladder means it's getting bigger. So now it's like you have tens of, whatever it is. So in this case, like this kind of funny example, it's tens of a, paper clip. If you go up to hecto, it means you have hundreds of paper clips. And if you go to kilo, it means you have thousands of paper clips. Whereas if you go the other way, you're making it smaller, you always have less than one of them, right? So you have a tenth, basically, there's a lot less of them, right? 100th of it, or you have 1,000th of it. You just have one little tiny section of the paperclip, right? So that's, the way that they're converting units with that metric system that goes in there. Some teachers will have you try to remember these steps of the metric system. This year, you do not have to memorize them. I'm not going to ask you a question and say, write down all the steps of the metric system. But just so you know, that's where that acronym, King Henry died by drinking chocolate milk, right? K for King, Henry died. By just means base units, right? Drinking chocolate milk, right? So just in case you've heard that and you're wondering what they're talking about, that's where it comes from. But yeah, you don't have to memorize that or anything like that. So here's what you do need to know how to do for the quiz that we're going to have after this video. There's a really short little quiz for you. You're going to be asked to convert metric units, right? So they might ask you a question like 10 meters. So imagine, okay, they're bigger than this, right? But, meters, 10 of them, right, is how many of the little tiny guys, the centimeters, right? Those little tiny guys that we're measuring in class this week, right? So how many, 10 meters is how many centimeters? Or you could write the shorthand way, right? 10 meters equals how many centimeters, right? So the steps that you need to do this, right, is first, you've got that number 10, right? Because we're starting with 10 meters and everything. So where is the decimal? Remember, we just talked about this. If there's no decimal already there, it's automatically right back there. You got it, right? Then what we want to do is we want to figure out which way. We're always just going to be moving the decimal. One way, this way, or over this way. That's kind of backwards for you guys, isn't it? Anyway, wait, let me try. This way or this way. That's kind of funny because it's backwards for me. Anyway, which way are we moving? So we're going from 10 meters. We're starting out at meters, one of the base units. And look, we're going to centimeters. So centi is over here. It's down this way to the right, right? So we know we're moving the decimal to the right because from here, I always tell people, imagine like this is the decimal because we're starting with 10 meters and you're moving it to the right, right? So how many places are we moving it to the right? Okay, so it's moving to the right. So you need to count. Look, the decimal is going to move one place, 2 places to the right. So for the 10, if the decimal start here, it's going to go 1 place, 2 places over to the right, right? That's how we're going to move it. So you can see it's going to be 2 spots, right? I often tell students, underneath of it, actually put like a little swoop on your piece of paper if you're writing this down on a piece of paper, and then put another little swoop right there. So you know how many spaces to put in there. Then all you need to do is fill in the zeros, right? Remember the decimal start here, 1, 2, you fill in the zeros, right? And then the last thing is, what were they asking for? They want to know how many centimeters it was. So the answer is going to be 1,000 centimeters were in those 10 meters that they had. Amazing, right? Let's try another one, right? So because these are the questions that you're going to have on your quiz in just a few moments. Let's try this one, right? If they have 75 millimeters, right, is how many meters, right? So that's the question. You're going from millimeters to meters, so 75. So step number 1, right? Centimeter, or the decimal goes right in there. Right? Oh, sorry. I'm even ahead of myself. 75 millimeters is how many meters, right? This is just the shorthand way of writing it, right? This is just the short way of how you can write it. So here we go. We'll go at the very beginning, right? 75, where's the decimal? Right there. There we go. Good job. Okay. Which way is it going? Now we're going from millimeters way down here. That should give you a hint right there, right? Because I told you, we're not going down anymore. Even though, yes, the metric system does allow you to go down, in science this year, we're not going to go further than 3 steps down or 3 steps up. So the decimal is definitely going that way. It's backwards again. It's going over this way. Look, it's going this way, right? It's going to the left, basically, right? So we know that. So next step, how many steps to the left is the next big question, right? So if we started at milli right here, and we're going to meters, so that's one of those base units again. Meter right here is a base unit. We're going to the left, and we're going to go, like I always tell people, look at the dots, right? We're going 1 space up, 2 spaces up, 3 spaces up, right? We're going over that many, right? From milli all the way to just the base units, right, is which way we're going. So for this one, it started out right here. We went 1, 2, 3, right? Because look, we went 1, 2, 3. So 1, 2, 3. Now you have those there. The 5 is kind of holding the place here. The 7 is holding the place there. But this one was blank because we just started out with 75. So you need to put an extra 0 in there. We're almost done, right? The only last step you have to do is put in what was the symbol they were asking for. Remember, we were converting from milli over to meters. So you just put the little m in there, and now you've got it. Okay, let's how about another one right here. They have 1.2 kiloliters is how many milliliters? Wait a minute. Oh my gosh, are they completely crazy? This is the absolute King Kamehameha. This is the hardest question you possibly could ever have for converting metric units this year in science, because they're asking you to go from thousands to thousandths, right? I mean, this is the biggest possible problem we could ever have, right? So we'll get through this together. So the shorter way you could write this, 1.2 kiloliters, right, is how many milliliters, right? That's the shorthand version of the same exact question that they have. Okay, where does the decimal go? Well, it's already there, 1.2, so we're good with that. Most people should be able to get that and everything, so you got that, you're amazing. Okay, which way is it going? Now, one good thing, again, about this being the worst possible scenario, because look, we're going from kilo, they're asking, 1.2 kiloliters is way up here, to milli is way down here. The good news is there's only one way that little decimal can possibly go, and that's downhill right here, right? Because I told you, while the metric system does get bigger, we're not doing any of that. So, okay, we're moving it over this way. It's trucking over towards the right and everything. That's good news. So how many spaces? Well, look, the decimal's here. Just follow the decimals. 1 space, 2 spaces, 3, 4, 5, 6 spaces over. So if the decimal started out right here, because it was 1.2, let me check. Yep, 1.2. So the decimal starts right here. 1, 2, 3, 4, 5, 6. And I can't stress enough when you're doing these. Either put like the little loops underneath the things, or maybe just put little dashed lines, kind of like right here, because the next step then is fill in the zeros, right? If it was 1, 2, 3, 4, 5, 6, right? Then you got to fill in 1, 2, 3, 4, 5 zeros for it. You're almost home free, right? The last thing that we need to do is put in the units, right? And for this one, it's milliliters because it's what they were asking for. They wanted to know how many milliliters it was for us. Shoo, you've got it. That's amazing, right? So now what we're going to do is practice. Now, normally the practice is on page 20, but we don't have the workbooks this year, so you're going to have practice by doing the quiz that follows this. So just remember, right, the steps. Hold on here. If we do one of these guys and everything, they're going to ask you, right, a number of, a unit, right, and you've got to convert it to another unit. So you always just want to check, okay, which way is the decimal moving? This way or that way? And how many places over is it moving, right? So that's where, this comes here. Either the decimal's moving this way to the right, or the decimal's moving up, that way, right? So just check which way it's moving, how many, fill in the zeros, and then, the units, and you've got it. All right, so check out the quiz. If you don't do well on the quiz, watch this again, and you can take the quiz another time, so you get some more points for it. Hopefully I helped out.